These are the solutions to Milham's Calc 3 Exam 2 for the 11 o'clock section. Number 1, find the domain of the function. Sine of t, that's no problem for all real numbers. The square root of whatever has to be greater than or equal to 0. So that has to be greater than or equal to 0, and that has to be greater than or equal to 0. So in other words, t minus 1 is greater than or equal to 0, and 5 plus t is greater than or equal to 0. This says t is greater than or equal to 1, and also t is greater than or equal to 5. They can both be swallowed up just with t greater than or equal to 1. So the domain is bracket 1 comma infinity. Number 2, these two are just straight plugins. The middle one, you could either factor the denominator and cancel, or you can do L'Hopital's rule. We call L'Hopital's rule. Limit as t approaches 1 of 1 minus t over t squared minus 1. If you plug in, you get 0 over 0. So L'Hopital's rule, that's LHR, means you can differentiate the top, differentiate the bottom, and get the same limit. So negative 1 over 2t. Then when I plug in, I get negative a half. The other is easy by straight plug-in. So 0, negative a half, cosine of 1. Number 3, x is e to the t, y is 1 over e to the t, which means y is equal to 1 over x, which we recognize goes like that. There's a branch in the third quadrant, but the third quadrant in this case is not possible because exponential function is kind of positive. Okay. R prime is e to the t, negative e to the negative t, and when you plug in 0, you get 1, negative 1. So the position vector is like that, and r prime vector, tangent vector, goes like so. Okay, number 4, r prime is 5, 3 cosine t, negative 2 sine t. Plug in pi over 3. 5, 3 times cosine of 60 degrees is a half, so 3 halves. And then negative 2 times sine of pi over 3 is radical 3 over 2. So I have 5, 3 halves, negative radical 3. To make it into a unit tangent vector, I just divide by its magnitude. So t of pi over 3, 5, 3 halves, negative radical 3 over the square root of 5 squared plus 3 halves squared plus negative radical 3 squared is 3. These come out to be 28 and 9/4, which is 121 over 4, whose square root is exactly 11 over 2. Put the 2 in the numerator. So 10, 3, negative 2 radical 3 all over 11 is your unit tangent vector. Number 5, quick mention that this last one, t sine t, you have to integrate by parts. You might recall doing integration by parts in Calc 2. That u would be t, dv is sine of t dt, du equals dt, v is negative cosine t. So the original integral I is u times v, negative t cosine t, minus the integral of v du, negative cosine t dt. So you're basically integrating cosine, which is sine. So negative t cosine t plus sine t plus c. And a quick double check to see if that's correct. Well, maybe I shouldn't go over that. If you double check that, it ends up working. But in any event, so the integral is 1/2 sine 2t, 1/2 cosine 2t, negative t cosine t plus sine of t. Okay, so plug in pi over 6, 1/2 sine of pi over 3 is 1/2 of radical 3 over 2, minus plug in 0, you get 0. Okay, then the middle one, the y component, plug in pi over 6, 1/2 cosine pi over 6 is 1/2 of 1/2 minus plug in 0, you get a half. And then the z component, negative pi over 6 times cosine pi over 6 is radical 3 over 2, plus sine of pi over 6 is a half, minus 0 plus 0. So radical 3/4, negative 1/4, and negative pi over radical 3 plus 6 all over 12. Number 6, dx dt squared plus dy dt squared plus dz dt squared is, so this one, the derivative is radical 2 squared, you get 2. This derivative is negative e to the negative t squared, you get e to the negative 2t. The derivative of this one is e to the t squared, you have e to the 2t, which very conveniently comes out to be e to the t plus e to the negative t squared. In other words, if you square this out, you get that. So by formula, I integrate the square root of that. Well, if I take the square root of a square, I just have to worry about e to the t plus e to the negative t, whose integral is e to the t minus e to the negative t. Plug in 1, you get e minus e to the negative 1, minus plug in 0, you get 1 minus 1, which is 0. So e minus e to the negative 1, which I'll accept like that. Or you can put as e minus 1 over e. Number 7, a little bit tricky, the algebra. So r prime is t squared 2t2. Unit tangent vector is to take t squared 2t2 and divide it by the square root of t squared squared plus 2t squared plus 2 squared. This very conveniently is t squared plus 2 squared, whose square root is just t squared plus 2. So t squared over t squared plus 2, 2t over t squared plus 2, 2 over t squared plus 2. But for finding t prime, I have to differentiate all three of these. It's best to think of this as t squared plus 2 minus 2 in the numerator, which is 1 minus 2 t squared plus 2 to the negative 1. It's much easier to differentiate that. This one I'll do the quotient rule. This one on right is 2 times t squared plus 2 to the negative 1. So you can tell right away that these two are going to have opposite derivatives, right? Because the derivative of 1 is 0. That has a negative 2, blah, blah, blah. That's positive 2, blah, blah, blah. All right, so ready for t prime? So I'm going to differentiate that. So positive 2, t squared plus 2 to the negative 2 times the derivative inside is 2t. The middle one, bottom times the derivative of the top, 2, minus the top times the derivative of the bottom, 2t, all over t squared plus 2 squared. And we already said that these two will be opposite in derivatives, so this one's going to have a negative. So clean it up, 4t over t squared plus 2 squared. This comes out to be 2 times 2 is 4, and you have 2t squared minus 4t squared. So 4 minus 2t squared over t squared plus 2 squared, and negative 4t over t squared plus 2 squared. And now I need to convert to a unit tangent vector. Okay. If I need a unit tangent vector, I can take any scalar multiple of this that's going in the same direction, which means I'm going to lose all the denominators, and I'll factor out a 2. Okay, so I'm going to lose the denominators. I'll use 2t, 2 minus t squared, and negative 2t for finding the unit normal vector. Okay, so again, this vector and this vector are in the same direction. They will have the same unit vector. Okay. So the unit normal is 2t, 2 minus t squared, negative 2t over the square root of this thing squared plus this thing squared plus this thing squared. This comes out to be t squared, t to the 4th minus 4t squared plus 4. And let's see, 4t squared cancels to 4t squared. I have the square root of t to the 4th plus 4t squared plus 4, which very conveniently is t squared plus 2 squared. Take the square root and you have that. So the unit normal vector is 2t, 2 minus t squared, negative 2t, all over t squared plus 2. Number 8, r prime is negative cosine, negative sine, cosine. Double prime is sine, negative cosine, negative sine. I will need the magnitude of r prime. So it's the square root of cosine squared plus sine squared plus cosine squared, which is 1 plus cosine squared t. I also need the cross product. So cross product of r prime and r double prime, I, j, k, negative cosine t, negative sine t, cosine t, sine t, negative cosine t, negative sine t. So the I component is that minus that, sine squared minus or minus cosine squared. J component is the opposite of cosine t sine t minus cosine t sine t. Well, of course, that's 0. And the k component is cosine squared minus or minus sine squared. So I get 1, 0, 1. Okay, the magnitude of that, magnitude of 1, 0, 1 is the square root of 1 squared plus 0 squared plus 1 squared, radical 2. Right, so kappa is the magnitude of r prime cross r double prime, radical 2, over magnitude of r prime cubed. Okay, so the magnitude of r prime was radical 1 plus cosine squared t. I'm supposed to cube it, so I'll write it as 1 plus cosine squared t raised to the 3/2 power. 9, r prime velocity is 1, 2t, 3t squared. Plug in 3, 1, 6, 27. Second derivative, a of t, not e prime, but a of t, is the derivative of r of the velocity, which is 0 to 6t. Plug in 3, 0 to 18. Speed is just the magnitude of the velocity vector. So it's the square root of 1 squared plus 6 squared plus 27 squared, radical 766. And finally, number 10, here's R. R prime is cosine t, negative sine t 1. R double prime is negative sine t, negative cosine t 0. Their dot product is that times that, plus that times that, plus that times that, which comes out to be 0. Okay, then I take the cross product, I, j, k, cosine negative sine 1, negative sine negative cosine 0. So the I component is that minus that, so it's minus a minus cosine t. The j component is the opposite of, see, nothing minus, oh, let's see, I have that right. Plus j component is nothing plus sine t. And then the k component is negative cosine squared minus sine squared, which comes out to be negative 1. Okay, I think I marked this up. This should be negative 1. Whoops. Get a little bit of focus here. So j component is that minus, so that's just sine t. Sorry about that. Cosine t, sine t, negative 1. Fortunately, this still comes out to work. So the magnitude of that is cosine squared plus sine squared plus 1 radical 2. And the magnitude of r prime is the square root of cosine squared plus sine squared plus 1 squared, also radical 2. So a sub t is 0 over radical 2, which is 0. A sub n is radical 2 over radical 2, which is 1. Okay. All right, so those are the solutions to exam 2 for Melham's Calc 3, the 11 o'clock section.